Hey, this is Brock Lemires, and in this video I'm going to continue getting started with the Arduino UNO single board computer, and specifically in this video we're going to look at analog inputs and variables. Okay, so the Arduino has it has six analog inputs, and they're actually called A0 to A5. So if you look at this little Arduino right here, you'll notice that they're down here in this lower left corner, and you see that they're labeled A0, kind of hard to see, but it's like A0, A1, A2, A3, A4, and R5, and it's labeled on there as analog input. And these are different than the digital inputs, which sit over here. So the first question is basically, what is an analog input? So if you imagine an Arduino, it's basically a chip. Okay, so it sits right here, and it's from Atmel, right? So you got this little chip right here. So this is your Arduino. The Arduino actually includes the board too, but let's just pretend this is the chip, okay? And we talked about digital inputs and outputs. So you have your digital over here, and digital means that you have highs and lows. So basically, you can think of a signal as like it's a low, and then it goes to a high, and then it goes to a low, and you can basically just do digital writes to this and make it go up and down. Now, when you send out that information, this is a 0, 1, 0, basically what it is it really is a voltage, right? I mean, it is absolutely a voltage. It's just that it's interpreted as the lowest level and then the highest level, and this it corresponds like 0 volts, and this corresponds to like 5 volts, okay? And so it's a discrete representation of information. So on an analog, and we'll look at an analog in, what you have is it can take on any voltage between a particular range. So this is where you might have something that looks like this. Okay, so it's not basically just going to be read as like, oh, it's low and it's high. It can take on any of the values that sit in between it. So then the question becomes, what are the values that it can accept in, and how does it actually interpret it? So if I came over here, you have a range of analog input voltages that the Arduino can take. And it turns out that it goes from 0 volts up to 5 volts. Okay, so you can't put in like 100 volts into this, not even 9 volts into this thing. What it'll do is if you do that, it'll actually just kind of clip out and give you the highest value. So you can only go from 0 to 5 volts. That's the analog input range of the Arduino. Okay, and then this signal is just brought into this little pin right here. And what happens though is that when it comes into here, it goes through this little circuit, which is called an analog to digital converter, and it converts it into a digital value. So it's a digital value is a set of ones and zeros that represent information. And like we've talked about, that an Arduino is a computer, and a computer operates on ones and zeros. And so these values have to be converted into ones and zeros. And so what it does is it basically is going to say, okay, I'm going to have like all zeros for this little thing right there, and then like all ones for this one up here, and then in between it's going to cut this in half and be like, okay, so then this is like 0, 0, 0, 0, 1, 1, 1, 1, 1, and up here is going to be like 1, 1, 1, 1, 0, 0, 0, 0, and it basically cuts the input into a bunch of different discrete ranges, and it assigns these different binary codes starting at 0 and going all the way up to all ones, and that is the value that you're going to get out of here. Okay. Now the question is, how many bits does it cut it into? And it turns out that the A to D converter on this is 10 bits. Okay. So if you wanted to think about how many different like ranges that would be in there, you can use this equation of 2 to the n, where n is the number of bits in the binary number. So if you said 2 to the 10, that comes out to be 1024. So with 10 bits of an analog to digital converter, you're basically going to create 1,024 different discrete ranges in there. Okay. Now that is what you get out of this little circuit in here. And what is amazing about the Arduino is that it is actually just going to give this to you as an integer when you start writing your program. So you don't have to even worry about whether it's 10 bits or how it converts it. All you know is that it's going to give you an integer value that goes from, basically it's not going to, there's 1024 different ranges, but what you're going to see when you use your software is it's going to go from 0 to 1023, because there's 1,024 different ranges, but the integer value that you'll see starts counting at 0 and goes up to 1023. So all the 1024 ranges are spread across that value. Okay, so what that means is that if I came along here, I would see when the voltage is really low right there and I read it, I'd have 0 as an integer, and if it's at its very highest point right here, I would actually get back 1023. Okay, so that's how it works. It's actually really simple. When you access these pins on the device of an Arduino, what's really cool is you can access them as the pin number if you want, but you can also just write in like A0, A1, A2, and it makes it really easy to understand. And then the function, of course, that you use, not of course, but the function that you use is called analog read. So I basically am going to use this function that's built into the Arduino. I say analog read from one of these channels, and then it will return to me in my software a value between 0 to 1023 as an integer. Okay? All right. So what we're going to do is ultimately get to a point where we're going to write a little program and we're going to make a voltmeter. Okay, so let's just read in some voltages to an analog pin on the Arduino, and then we're going to print it out. Okay, but this brings up the next concept when programming an Arduino, which is where do you put information? You know, when we looked at digital outputs, it was really simple. We just wrote highs and lows to the pin, and it just went out as a voltage. But now we're going to read information into the Arduino, and it's going to sit inside as ones and zeros, and we'll interpret it as an integer. And so we need a place to put it. So that's where you introduce this concept of a variable. A variable is a location in the data memory, which is going to allow us to temporarily store information. Okay, and so when you have a variable, this is what it might look like out there. It's it's just this massive like table of information that sits in the computer memory, and you basically stuff stuff in there, and then you read stuff out, and et cetera, et cetera. So a variable is always going to have three things basically. It's going to have a name that you're going to give it. It's going to have a type, and that's what we got to talk about now. And then we got to talk about the value. Okay, so it's going to hold some piece of information that sits within it. All right. So now here's what is kind of an interesting concept about computers. It's when you have a variable, it has a data type. And what is a data type? Well, we talked about how a computer only stores information in terms of ones and zeros. So even an analog signal, the first thing that happens when it comes into the Arduino is it goes through an analog to digital converter, and it's converted into ones and zeros. So what is a data type? And it is how you interpret that. So this particular string of ones and zeros, if you said it's encoded as an unsigned decimal number, this set of ones and zeros might represent the decimal number 169. But you could also have that same group of ones and zeros and interpret it as a signed decimal number, and this could potentially represent -87 in base 10 or in decimal. And you could also interpret it as a character. It doesn't mean it doesn't necessarily mean that you have to represent it as a number. It could actually be a character that is in the English language, or any language actually for that matter. So you can interpret it that way. So a data type means how you are going to interpret the ones and zeros that are stored into memory. Okay. All right. So the Arduino has three primary data types. In fact, most computers have these three primary data types. The first is going to be called an integer, or int. Okay. So int. And what that is it's going to store a whole decimal number. So an example of that would be 101. You could also have like an integer that's like -99 or whatever, but it's a whole number, and you create a variable and you give it this data type int. Okay, so that's an integer. The second data type is called float, and that stands for floating point. And this is how you represent real numbers. And a real number is anything with a fractional component. So like 3.14 is a real number. Now, floating point, where that comes from is that's just the encoding technique that somebody made up of how to use ones and zeros to represent real numbers. And it's, it's relatively complicated. You'll learn about it as we go through electrical engineering. But for right now, all you got to know is that if you define a variable as a data type float, it can take on a number like 3.14 or something real. And then the third one is going to be called character. And that's basically going to be like uppercase B, lowercase a, etc., etc. All right. And so these are the three characters. So this is an example right here of how you would create a variable in your Arduino sketch that is called raw voltage. Okay, and it's going to be an int, meaning that this variable name, raw voltage, can hold an integer. All right, and you can basically just say raw voltage is equal to something. And in fact, we can do the raw voltage is equal to analog read, and it will actually read from the pin. So this is kind of cool. So a couple nuances of other things that you can do with variables is if you wanted to say, I want to make a variable that never changes, like you cannot overwrite it during the course of your software execution, you can put this this name const in front of it, indicating that it would be a constant, and then you would give it some initial value. So like in this situation, I said int raw voltage. I could have said int raw voltage equals 0 to initialize it, and I could have put const in front of it to make it a variable that you could never write to. So that's how you set up basically just constants. Okay, so let's fire up a sketch and let's see if we can program the analog input of the Arduino. Okay, so I'm gonna come over here and I got my Arduino right here. So I'll go ahead and double click on that little sucker and I come up with my new sketch. Okay, so just like normal, just like always, I'm gonna save this right away so that I can save it where I'm working. And so I'm kind of working on my desktop right now for this video series. And what I'm gonna do is I'm gonna call this sketch 02, let's just call it voltmeter. Okay, we'll have to remember as we go that that's an analog input. Okay, all right, so I save that little sucker up. And then when I look at what's going to happen on the Arduino, I've got my little Arduino here. And what I'm going to do is I'm actually just going to use some of the voltages that are built in to the Arduino, and I'm going to see, I can basically go to 0, 1, A0, excuse me, A0. And I can try to connect it to a couple different voltages. I can do ground, I've got +5, and I've got 3.3. So I should be able to see like the lowest integer read in, the highest integer, and then something in between. So let's get that working first. And then what we'll do is we'll figure out a way to convert the thing. Okay, so I've got my little Arduino here. I'm gonna plug this in and I'll try to keep it right side. Okay, so I got that little guy on there and I'll put it right here. Okay, let me do that. All right, so there it is. Okay, so I'm going to come into here, and one of the first things I want to do is I need my serial monitor, because what I want to do is I just want to print out the analog input that I get. Okay, so I'm going to do my serial begin, and I'm going to go 9600, and that, if you remember that from prior videos, that sets up the communication link over a serial cable, which is USB, between the Arduino and the actual serial monitor of this thing right here. Okay, so I'm going to set that up right there, and then I can do serial print, and I can say voltmeter, just to make sure and then we'll do carriage return, excuse me, carriage return, Jiminy Creeks, Jiminy Creeks. Okay, there we go. And so good to go. All right. So now I'm going to come down here, and what I want to do is I'm going to do this following function. I'm going to say analog read. Okay, and I'm gonna write this in little pieces so that we can kind of construct it together. So analog read is the function, and what I do is I then open it up and I give it either the input pin number, or I can use these descriptive names like A0. So when I do A0, what's going to happen is that I'm going to actually be able to read from that thing right there. Okay, so now what I need though is I need to assign this to some variable. So over here, I'm going to make a variable that is going to hold that. Okay, so what I'm going to do is I'm going to come up to the top and I'm going to create a variable that is called raw voltage. Okay, and it is going to be of type int because this analog read function returns an integer when it reads from the analog pin from 0 to 123. So then down here what I can do is I can just say raw voltage is equal to analog read, and it will go read from A0, and then it will put the information into raw voltage. And remember, it's an integer. Okay, so now if I want to see that, I just do a serial print and I do raw voltage, and there I've printed this integer to the serial monitor. And then what I should do is I should probably print a return just so that they're all kind of on top of each other, so it'll just scroll. And so what I have to do is I have to do this like this, and let's talk about that for just a second. So when I do this Arduino, the simplest way to get started is that if you're just going to print the contents of a variable like I do on this one right here, I do print contents of raw voltage variable. I can't necessarily, it's easiest just to print that like that, and I don't put any parentheses on it or anything like that, and it just prints that raw voltage value. Okay. But when I want to like put additional text around it, such as a carriage return, or maybe I want to put like the raw voltage is equal to this, then I have to put it in like these double quotes. And I do that in a totally separate print statement. So let's do this first, and then we can kind of clean it up and make it look better. Instead of running like as fast as we possibly can, let's do a delay of just 100 milliseconds, and then we'll loop forever. So let's get this working first, and then what we'll do is we'll come back and we'll make it kind of clean. Okay. All right. So I'm going to go ahead and I'm going to verify and upload. I went ahead and just let it ride. So one of the things that you notice is I just plugged in my Arduino. It knows from the last project that I used that we have this Arduino Uno and it's on COM3. Okay. All right. So look at this. Look what's happening. It's just printing all this stuff. It went so fast I didn't even see my voltmeter statement, but I could actually come in here and I could start it again. So let me hit reset on this thing and see if we can catch the voltmeter. It's gonna fly by. There it was. Did you see it? Did you see it? You see that? It goes boom, voltmeter. Okay. And so it's just streaming information. All right. So now you go like, what's the information? Well, first of all, it is a number, but we don't know really what voltage is on there because right now we're not driving A0 with anything. So let's go ahead and drive something to A0. So I'm going to take this wire and I'm going to plug it into A0. And you got to be careful here. You don't want to short stuff up. But now what I'm going to do is I am going to plug this into a voltage. If you look right next to here, you have a power bank or some power pins. And there's one that is +5, there's one that's ground, and there's one that's 3.4. So let's do ground first and see what happens. So I plug this into ground. This is the lowest voltage in the system. And lo and behold, the thing goes to 0. So it's printing zeros out there. Every once in a while it prints like a 1 just because there's a little noise on there. But that represents the lowest voltage that the analog input can take on. Let's go to 5 volts. Okay, so I come over to here to 5 volts and I plug that in. Holy buckets. It's 1023. Sometimes it's 1024 due to noise. Look at that. That's the highest voltage in the system. And then if you look right next to +5, you actually have +3.4. So if I come over here and plug it in there, it's going to be some value in between. So it's like 682 or something like that. So this indeed is working. We are actually reading in an analog voltage and we're printing it out in its raw value, which is an actual integer. But what I really want is I want the serial monitor to print the actual voltage. So instead of printing an integer between 0 and 123, I want it to print like plus 3.4 volts or plus 1.5 volts or plus 5 volts. So we need to do a little conversion factor, okay? So let's think about what we can do. First of all, I did change my USB cable because I'm trying to orient it differently. So you're not crazy. It did change from blue to gray. Okay, so let's think about what is happening here. We have a function that takes in, we're going to create a function that takes in something that goes from 0 to 1023. Okay, so that's the input and we'll call it X. Okay, and then what happens is that corresponds to an output that goes from, this is going to be voltage, 0 volts up to 5 volts, and this is like, and everything in between. Okay, so like in between you got 2.5 volts. Okay, and then what happens is that it's basically a straight line. Okay, so it goes like that, where this and this intersect right here, and that's the maximum value. All right, so if you think about a function, you essentially have y is equal to mx plus b. So then you come in here and you go, well, what's the slope and what's b? Well, b is 0 because it intercepts at 0 on the y-axis, and so the slope is going to be rise over run, and so the rise for this is going to be 5, and the run is going to be 1023. So if you think about this, the slope can be replaced by 5 over 1023. And so I can have an equation where instead of y, let's say the voltage, the real voltage is going to be equal to this conversion factor, which is 5 over 1023 multiplied by x, which is going to be the integer that comes in on the analog read statement, and then plus 0, which is nothing. So this is what we actually want to implement in our code. So let's do it, and let's see if we can get this thing to print something a little more meaningful. So the first thing I'm going to do is I'm going to come out here and I'm going to come up to the top and I'm going to create a new variable called float, and I'm going to call this real voltage. Okay, so what we're going to do is we're going to read it in as an integer, so we have to have this int right here, and then we're going to have a conversion, and then we're going to store it in something called real voltage. Okay, so this is variable to hold analog input integer value, and then this will be variable to hold converted real integer integer value. And then let's make a constant, which is our slope. And so if you remember, I'm going to give this thing, I'm going to do this. I'm going to say, I want this to be of type float. And I can just say it's going to be called slope, for example. And I can actually say equals, and then I'm going to do 5 divided by 1023. And this is going to be the slope of my conversion function. Now, there's a couple subtleties here that I want to talk about before we use the const. When you do this right here, if you just put 5 divided by 1023, it interprets these as integers, and so you don't get all of the precision that you would expect. And so what you have to do is if you're going to set up some like variable that is defined with an expression over here, and you want it to be floats, you got to do 5.0 and 1023.0 so that when it interprets this, when it compiles it, it says, oh, he doesn't mean 5 integer, he means 5.0 real. Okay, so it's real subtle. If you don't put these point zeros there, your numbers won't work out, and you'll be like, this sucks. Okay, so then I do want to come over to this part, and I want to say const. Okay, so now what I've done is I've created a variable called slope. I've initialized it with a value that I'm going to use, and it's of type float, and it's going to be a constant. Okay, so then this is going to be my code. Okay, and so I'll comment these over or tab these over so that they look all real nice. And now let's come down here and let's think about how we're going to do this. So I read the raw voltage right here, and then let's do this. I'm going to convert this. I kind of want to see my variables here. I want to do this. I want to say real voltage is equal to the raw voltage, times slope. And you go, why'd you do that? And it's like, well, that's the equation that I'm going to do. So that'll convert the integer value to a real number between 0 and 5 volts. And I did it. Okay, so the next thing I need to do is let's print these out, and we'll print them out and make them look real cool here in a second. But what I want to do is I want to print the raw voltage, and then I want to just print like a tab. Okay, and you're like, how do you do a tab? Well, it turns out you do this. You go tab. So you basically just do /T, and that'll do a tab. All right, so this is how you learn this stuff. You just, whenever you need something, you look it up, you figure it out, life is good, okay? So then I had to put that in double quotes because that's like an actual formatting thing, or real like text. And then I do serial.print, and I'm gonna do this. I'm gonna do real, boy, these pop-ups are super annoying, aren't they? So I'm gonna do real voltage, and then I will do serial print return, and we're done. So what this should do is it should print 2 columns of information. One is the raw voltage and one is the real voltage. Okay, pretty sweet here. We've done math. We've set up different types of variables. One of them was a constant, one of them was a float, and now we did math. Oh boy, let's check it out. So let's go ahead and do this, and we'll see what happens. And remember, right now we have it wired to, let me disconnect the wire so we get like a clean start. Oh, look at this. Look at this. I see my integer, and I see a real number, which represents a voltage. Let's go test and see if it's actually right. So let's go back to A0. I do my A0. And then I'm going to go, let's do ground again. So it's like ground. Oh, 0 volts. All right, let's do 5. Let's go 5. Oh. And then let's do 3.4. And it's like, 3.4. Oh, my nugget. Look at that. Look at it. That's so cool. Let's make it pretty, and let's just pretty this up really quick, and then we'll be basically done, right? So before I do the real voltage, after I do a tab, I want to put plus. So what I can do is this. I can do serial.print, and there's a lot of different ways to do this. So you're going to be like, I could have put it on the line before, and that's true. But I'm going to say plus, then I'm going to print the voltage, and then I'm going to put the units, which is going to be V. Okay, so I'm going to do this. I'm going to go space V. And you can see that it's like I could have put the line return after the V. I could have put the plus after the tab, but it's like it doesn't matter, right? These are small programs, so let's just let it ride. So let's do that, and let's test this one more time, and then we will have completed a voltmeter. And let's test it on something that's not on the Arduino, so that I'm not cheating. Oh boy. Okay, so it's printing what I wanted. That's pretty sweet. Let's test it one more time with like a ground 0. Let's do 5. Oh, baby. Now let's prove it to ourselves that this actually works. I want to see if it can measure this. This is a 1.5 battery. Now to do that, I actually need to connect to both sides of this. So I need to take the negative side of the battery and connect it to ground, and then I'll touch the positive side to there. So this is still going to be the analog 0. So I do need to get a ground out of here. So I'm going to put up this little sucker right there. And then what I'm going to do is I'm just going to hold it on there. So I'm going to take the battery, I'll hold it right here, and that grounds the negative side of the battery to the Arduino ground. And now what I'm going to do is I'm going to touch this, and we'll see if it gets to 1.5. Oh my goodness, 1.5. You have made a voltmeter. So what's cool about this is that you could actually measure like resistance, or you could measure voltages using this little guy, right? So here's your shield. You could actually plop that thing in there, and you could actually build little resistive divider circuits, and you could actually measure the voltages on there and verify that what you think you're building is what you're giving. And that is it. All right. That is a voltmeter. That is analog inputs, and that's an introduction to variables. All right. We'll see you.